was laughing with Anna.
Wait, really? Did you really forget? Yes. Well, you did talk a decent amount, and you're supposed to be that's fine.
That's the only reason I can try. Yeah, I'm sure.
You probably did. Yeah, it's normal P. Oh wait, is it P hat?
First of all, I forgot all.
Because we're finding something.
I got like
4-day weekend, you guys just forget everything.
It's an expiration
It was
date.
very
I forget
After 1 day.
after 5 minutes. Yeah. It just expired.
Wait, why isn't this yeah, there's on purpose. That's good.
I remember that.
All the famous people will say that. Come on. Stop. I know. It's so good. I'm going to hide it. I'm going to go. What? You have an extra ticket? Why? Why do you have an extra ticket?
Oh. Find the
You're
sequel
going
side.
online.
Well, I just had bad
Oh,
deja
go.
vu.
There you go.
Oh.
How much is it? Honestly?
There,
Honestly?
I got Rise.
It's the one
Did you?
on
Hey, you want my lunch bro?
What's that to do with it? Oh gosh.
His wallet got stolen. Be a good
He
friend.
didn't have money in it anyways. He had 64 cents in it.
I had a negative 35. They
Still
still
have
have
money,
money.
Eric.
While I was at the gym, I got an email that said there's
They're
like
very
an
underrated.
attempted transaction at Walmart for $316. And so obviously didn't go through because I have negative 35 cents. And so I just ignored it because I thought it was like a spam.
Uh-huh.
And then I found out my car got broken into, so I was like, oh, okay, that makes sense.
You check your email
Well, if it's from Chase, yeah.
at the gym?
Before the wire.
I got an email and a text.
Oh. What were they trying to buy?
No idea. Whatever is worth $360. Do you imagine how embarrassing that is?
Decline.
Did they use your own card?
Anna.
They probably swiped it as like, oh, yes.
All right. We're working with 90%. So to find your Z star for 90%, you have to do inverse norm. What's the area you put in there?
1.96. Oh no, don't listen to me.
I won't. Just messing with you, Maddie. What's the area? 0.95. 90% is in the center, which leaves the 5% for the edges, so we put 0.95. Mean is 0, standard deviation of 1. Now, with 95, a Z-star for 95, when you type it in the calculator, you get 1.960, blah, 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 blah. So I went to 2 decimals because there was no point in putting 0. For this one, when you type it in there, I don't know what you actually get for all the decimals, but you should go to 3 decimals. So inverse norm, it's too bright. There we go. So we have 0.950 for the mean, standard deviation of 1. Tail is left if it asks. You get 1.6448. I want you to go to 1.645. Go to 3 decimals for your Z stars. because if you look at the back of the book, that table goes to 3 decimals. They actually put the 0 on the 1.96. I just cut the 0 off because that's odd to me to put the 0 there. Seems pointless. But so 90% we use 1.645. 95 I just cut the 0 off. But so go to 3 decimals if there are 3 decimals for your z-stars. So we have our z-star. And then the formula for margin of error is z-star times your standard error, the square root of p hat times 1 minus p hat divided by n. P hat is what they expect, which is about 70%, so she put 0.7 in for p hat. The margin of error is 0.04, so she put that in for the margin of error. And then she used her algebra skills to solve for n. Remember, a lot of times these are multiple choice questions, and they'll give you options like A is 350. I don't know why I put an equal sign there. 350. B is 360. C is 375. Which one do we choose? 360. Go close to it, but if below it, you don't use. So the closest number that is greater than the answer you got.
Why do you square?
Say that
Yeah,
louder.
Why do you square by 2?
To get rid of the square root.
So if it was 351, you still pick B?
Uh-huh.
You're not bad at that. Why do you put it?
All right. So, first thing, as I was preparing last week, I realized I'm a dork. I think you guys are pretty used to that fact. A few years ago, like 2 years ago, I I can't speak. I put these two together, and I forgot to change it on my overview. So we've already done both of those lessons.
Oh my god, another day.
So you're not going to do this homework.
Oh, wait.
And
What's it
if
doing
you
anyway?
notice, Friday is a work day / review. I'll hand out the review packet on Friday.
Already? I got 6, 7, and 8.
You'll also have that day if you're behind in assignments to get caught up, or if you need to take a test, be ready to take it in class on Friday instead of having to come in outside.
Or retake it.
And then, or retake. And then next week, I see you on Monday. That'll be the official review date. Okay, so if you don't finish the review packet on Friday, don't worry about doing it over the weekend because you'll have time in class on Monday. And then your test is still going to be on Wednesday. I don't do Monday tests. They've never
Let's
worked well.
go.
So, yes.
So, do we have to do the 3.3 homework then?
Yeah, today's homework is going to be this one.
Excellent.
Don't do that one. Can I move it out
Go for it.
now?
Go for it. Oh my god.
I was bright.
My bad.
What are we not doing?
3.3.
Basic?
Yeah. The 505.
Okay.
Because you marked it down. Oh, goodness. All right, so today we're gonna look at means. Maybe, like, there we go.
Wait, why is your thumb so stubby? Huh? Why is your thumb so stubby?
That was random.
Video.
Okay. I feel like he's picking on you too much today. He had a bad night. You just keep picking on him.
Should have locked your car, dude.
It was locked.
The windows were smashed.
Should have locked your windows, dude.
All right. So, suppose that we're interested in estimating the average midterm exam score for all of the current NMHS AP Psych students. Exams follow a normal distribution. We're going to pick an SRS of 4 students, and we're going to create a 96% confidence interval. The standard deviation is 10, and the average is 82.5. How did I get the average? My husband gave me 4 test scores. We do talk. Imagine that. We're married and we talk.
Are you?
Actually married? Yeah. For almost 9 years.
Whoa.
9
I
years?
thought that was recent.
No. Almost 9 years. Actually, this last weekend was the anniversary of when he proposed to me. That was 9 years ago. All right. State. We want to state the parameter that we want to estimate and at what confidence level. We can start with the confidence level. What's the confidence level? 96%. And what are we estimating?
Texting my insurance.
You text
It can wait. What are we estimating? Sorry, Eric got me off.
The average midterm score.
True.
I should have said AP Psych midterm scores. Would have been shorter that way. Am I off the board? Gosh.
That's okay.
Yeah, I'm just rethinking my lesson plan as I'm going through it. No, you guys just don't seem like the type that would like me very much if I go through with it.
We all like you.
I'm gonna.
Didn't change it.
Take it.
All right. I am gonna change it up, but we're gonna keep going for a second.
Mental break.
Plan. What do we do on the plan?
We say what we're going to do before we do
Very sick.
Pretty much. And we check our conditions.
Oh
it.
yeah.
Yes.
So what are our conditions? Random,
Brand.
normal,
That
independent. Okay, how do we know it's random?
SRS.
It says it.
Tells us SRS of 4. So we're just gonna quote that. How do we know it's normal?
You have to check using the map.
What?
Greater than 10%, right?
And
No.
B is
No.
greater than or equal to 10, and n times 1 minus b is greater than or equal to 10.
So that is true if we're working with proportions. We switch to means.
Then n is greater than or equal to 3.
This is for proportions. Hannah, what did you say?
Oh, I said n is greater than or equal to 30.
N is greater than or equal to 30. If the population is non-normal. Or it'll just tell you it's normal. Like it does. So we get to just quote here. And then independent is the other one that you guys were saying. I think Zach said it. Didn't you say it, Zach?
Greater than 10%.
The 10% condition.
Oh,
So our sample size is 4.
yeah. Is that less than?
That's less than or equal to. So then we'd multiply both sides by 10. And I'm going to be honest, I don't think he has 40 in the class anymore, does he?
No.
No. But we're going to pretend that there's 40 in there.
Extrapolate.
Wait, what? Grandma.
Are you thinking
You times 10 to get the 40.
Yeah. So here's where I'm going to change it up. I was going to have you guys find the interval, make your conclusion, and then I was going to tell you what you did wrong. But you guys don't seem like the type who would like to go through the whole process
I would love to.
and learn that you
I'm
did it
practicing
wrong.
the right way.
So,
You can do it by
we're gonna jump down here. Okay? So we have switched from proportions to means.
Or just be copying this?
Yeah, this is part of my notes. And does anybody remember the very beginning of the unit? I told you there was a slight change between the formula for margin of error for means and proportions. It was a very long weekend. Nobody remembers?
I don't remember this either.
What is it, Maddie?
Huh?
What did you say?
B star and Z star?
Proportions, we use Z star. Means, you use T star. So my original thought was you'd go through with doing all this, you'd use Z star, and then I'd be like, haha, you did it wrong. But then I read the room and I thought, you know what? This group does not seem like the type that'd be okay with me being like, you used the wrong little thing. So, the one thing though, if I ask you to find a sample size for means, you use Z star.
What?
T star, if you go into your calculator, I'm going to get into T star more in a minute. But if you want to find your T star, so to find Z star, it's inverse norm. To find T star, you go to the same place, but right below it is inverse T. That's going to help us find our T star. But to find T star, you have to know degrees of freedom. Degrees of freedom is based on your sample size. So if I ask you to find a sample size, the formula to find the margin of error is T star times your standard error. Well, you can't find T star if you don't know N. So if I ask you to find your sample size, you do use Z star. If you're finding the actual interval, use T star. I want to color it stands out more, sorry. So there is a situation where you use Z star with means. Otherwise, you use T star. So we're going to practice finding a sample size for a mean. So we're still going to work with the AP Psych class. So what sample size is necessary for our 96% confidence interval to have a margin of error no more than 4 points? So like I said, T star, you have to know the sample size to find it. So here, we're going to use the margin of error is equal to Z star times our standard error. When working with means, you don't change it to decimals. So we want a margin of error of no more than 4 points. So we're going to put 4 for the margin of error. Notice in the warm-up, we wanted a margin of error of 0.04, or I would say 4%. That tells you you're working with proportions. Here it says a margin of error of no more than 4 points. I leave it just as 4. To find our Z star for 96%, we're going to do inverse norm. What's going to be our area? I'm sorry, say it louder, please. Thank you. So remember, you have to add one of the tails. 96% is in the middle, which leaves 4% for the 2 tails. So 96 plus half of 4, 2 is 98. Second bars, number 3, inverse norm. So we're going to go to 3 decimals. So we have 2.054 when I round, because that 7 tells me it round up. Up in the original problem, I told you that sigma is 10, so we're going to put 10 in. And then we're going to use our algebra skills to solve for n. So what should be our first step? Divide both sides by 2.054. Now remember, when you show your work, you're going to round, but I suggest using the answer the calculator gives you. So on my paper, I might write 1.95, but in the calculator, I'm going to use the answer so that I don't have a rounding error. All right, now what do I do?
Multiply by 10.
I'm going to multiply by the square root of n to get rid of the fraction. So I have 1.95 times the square root of n equals 10. And then I'm going to divide both sides by the 1.95. And this is where I'm talking, use the answer from the calculator. So when I type it in, instead of typing 1.95, I'm going to hit 10 divided by second negative, and it'll take the previous answer. And I get 5.135. And of course, my handwriting is too big. So those go away. Square root of n is 5.135. And then what would be our last step? We're going to square both sides. So I get 26.368. So what's the smallest sample size that I would use? I heard somebody mumble, but I don't know what they said. I think somebody said 27, but you guys forget that I'm old, and this makes noise the entire time. Gotta talk louder. So we would use a sample size 27 at the smallest. Questions? All right, now, yes.
So when you divide by 1.95, like, would it still be right? Okay. Like instead of bringing an answer down,
In this case, yeah, it would end up, because you get, if I do 10 divided by 1.95, sometimes the rounding can make a big difference, more so with proportions, because you have a lot more to undo. But in this case, it didn't make a difference. I would just get in the habit of using the answer, though, so you don't happen to round that one time it is going to make an issue. Any other questions? All right. So, see, this is where I was going to be like, surprise, you had a really, really big issue in the math you just did, but I figured you guys wouldn't like me if I did that. So, if, you wouldn't. If, we assumed that we knew sigma. I just put it in there. I threw it in there. I said, oh, sigma is 10. I just threw it in there. Told you that it was a certain number. But if I take a sample of size 4, do I really know sigma, or do I know the sample standard deviation? I know the sample standard deviation. So if you know sigma, you know all the data for the population, so why are you trying to estimate it? Yes, do you like my word? Nate's not here to appreciate my word preposterous. So, when we don't know sigma, we have to use our sample standard deviation to estimate sigma. The sample standard deviation is S sub x. And if we don't know sigma, we can't use a normal curve, and therefore we can't use z-scores, which really is what z star is. It's a z-score. So we have to use t-scores. And to work with t-scores, that means we're working with a t-distribution rather than a normal distribution. So z-scores, which really is what z star is, we would find, the calculator would find by taking our sample average minus the mean, and then dividing by sigma divided by the square root of n. We don't know sigma, so we have to use t star, which is pretty much the same formula. We still take our sample average minus the population, but instead of sigma, we use the standard deviation from the sample to estimate. So this is what we did before. And now with means. But like I showed you, the calculator is still going to do it for us. We just use inverse t instead of inverse norm. Can I move up? No. Okay. Are we good now? So, we are gonna, well, you know what, let's start by putting our normal curve here. That's our normal curve. A t-distribution is specified by its degrees of freedom, which are calculated. It's a really, really complicated formula. You take your sample size and subtract 1. Somebody finally laughed for me. Thanks, Anna. I try to be funny, but sometimes I think I'm only funny to myself. So if we were to have, well, I'll draw it in a minute. So as the degrees of freedom increase, your sample size gets bigger. The t-distribution becomes closer to the standard normal distribution. That's because your sample standard deviation estimates sigma more closely. Sample size increasing, always better. So, a t-distribution No, this isn't going to be perfect. You guys don't have to get really good at drawing them, okay? But let's say I have our sample size was 4, so that means my degrees of freedom was 3. A t-distribution with degrees of freedom of 3 is going to kind of just be a mound. We put a t to tell us it's a t-distribution, and then our subscript is the degrees of freedom. So we were looking at a sample of size 4. 4 minus 1 is 3, so my degrees of freedom is 3. I told you as your sample size increases, the degrees of freedom increase, it becomes more normal. So let's say that I increase my degrees of freedom to 10. It's still going to have more of a mound on the sides, but it's going to become more and more normal. And as I get higher and higher in my degrees of freedom, it starts to take on a more normal shape. The spread of the t-distribution is more than that of a standard normal distribution. The t-distribution has more probability in the tails. It's because it's more rounded or mounded. It's also because when you substitute the estimate S sub x for the fixed parameter sigma, it introduces more variation. More. And this is where, see, I was going to have you do it wrong, tell you did it wrong, and then have you do it correctly. And I figured you just really didn't want to do something wrong in your notes. So, same situation, estimating the average midterm score for the AP Psych students. We selected an SRS of 4. They had an average of 82.5. We don't know sigma, so we use S sub x to estimate. And you guys said, how did I get 82.5? Well, that's because the 4 test scores were 91, 79, 67, and 93. If you have the test scores, you can find the standard deviation for that sample. Anybody remember how to do that? It was a long weekend. Stat what? Edit.
Put the numbers in.
Stat, edit. And 93. Oops, how did I could have sworn I typed 79, but it didn't go in. Now what?
Go to 1 bar stack and then have 1. Right?
Yes. So once you have your 4 in there, go to stat, go over to calc, 1 bar stats, list 1, no frequency list. Average 82.5, I didn't lie, and then S sub x, excuse me. Let's go to 2 decimals. Did you have a question? Hit stat, go over to calc, 1 bar stats. Yep. It's all coming back full circle. See, I did teach you things in the beginning for a reason. All right, so we're gonna go with 12.04. So state, we already did that on the previous one, but we're gonna restate it here as well. So we want to estimate the true average midterm score, true average AP Psych midterm score. And we want 96% confidence. Now, just like before, with proportions, the calculator will find the confidence interval for us. It's a different calculator function because we're no longer working with proportions, we're working with means. Excuse me. This one is called t-interval. For proportions, it was one prop, one proportion, z-interval, because we were using z-star. Now we switch to t-star for means, so we call it a t-interval. Conditions, random, normal, independent. Random, still SRS of 4. So I'm going to quote it. Normal, we would use n is greater than or equal to 30 if we had a non-normal population. But up here it tells us that they follow a normal distribution. So we're just going to quote that. And then independence, that's the 1/10 of your population, which, like I said, isn't true, but we're gonna go with it so we can actually do our example problem. Any questions before we do the do? Yes.
Could you go over the calculator again?
For which part?
For the, where you enter the
To get the standard deviation? Yeah. So if you go to stat, go into edit, then you can enter your sample. And then once you have those in there, you hit stat again, go over to calc, and 1 bar stats. My data was in list 1, and then I hit calculate. Average, which I had already told you, 82.5. Standard deviation is 12.04. Good. Okay. Any other questions? All right, so on the do, even though the calculator does the interval for you, remember you kind of have to list the important parts. So the calculator is going to find the interval by taking our estimate plus or minus our margin of error. That's the most general form of a confidence interval. Working with means, our estimate is x bar. And our margin of error comes from T star times your sample standard deviation divided by the square root of your sample size. So I need to make sure that I state what my x bar is, my t star is, s sub x, and my n. So x bar, I already told you, is 82.5. S sub x is 12.04. And then we need to find our t star. I'm going to put the calculator up. So to find t star, instead of inverse norm, we use inverse t. Same place as inverse norm, so you're going to hit second bars. And this time it's number 4. Same idea with area. 96% is in the middle. We need to include a tail, so we would have 0.98. And then degrees of freedom, remember I told you is your sample size minus 1. Our sample size is 4. 4 minus 1 is 3. And then paste. If you're working with an old one, I was going to say, I think this is where it doesn't have it. I can actually write a program in your calculator to have it for you.
I can just borrow one.
You can just borrow one. You can. Anybody else working with 83?
Yeah.
Nope. All right.
I'm just gonna do it.
No, don't get a new one. It's actually not a hard program to write. I'm gonna put it in there.
Don't worry.
Programming now.
All right. So we get 3.482 for our t star, 3 decimals.
Why did you put 98?
Because remember, it's the area. 96 is in the middle, so we have to include one of the tails, just like with z star. I'm sorry.
Did we get it?
So,
I got a really huge number.
hold on. T star inverse T area is 0.98. Degrees of freedom is 3.
Oh, never mind.
You're
I
good?
put 0.3.
Okay.
Why did I get 13 plus?
Any questions before we have the calculator make it for us? All right. Yeah. So, T interval, same place as 1 prop Z interval. Do we remember how to get there? We're gonna hit stat, go over to tests.
And it's A.
That was what we used before for proportions. Now with means, it's T interval, which is number 8. There are 2 options. Notice it asks for data or statistics. We're going to use statistics right now. So make sure stats is highlighted and hit enter. Now, since we put our data in our list, notice it pulled my average and my standard deviation for me. Yours should do that as well. if you didn't put the data in a list, you would just type it in like normal. Over it says number. So it has my average. Yes, Michelle?
The confidence level to like 0.96, or would you add the tail?
You do the without the tail.
Okay.
Did you guys leave it like that? You okay if I leave it like that instead of rounding? Okay. So then we do change it to 0.96. So you don't include the tail here. And then you hit calculate, and the top 61.536 to 103.46. Concluding or interpreting is the same idea as it was with proportions. We would say something like we are 96% confident that the interval, and then give your interval. I don't know what I'm writing. I was going to say we were. I wanted to say we are. What did I get?
How did you get that? Well, you just wrote that.
This?
Yeah.
The calculator gave it to me.
I got
What? Are you sure? I feel like you're not sure.
I was gonna ask if you could like show us like how you would do it without the calculator, because you have a formula up there.
This?
Yeah.
Do it by hand?
No. Why would you want that?
I can show you in a minute, Michelle. Let me write my conclusion first. By hand. That's how I had to do it back in the day. So, hey, I'm not that old, but I am old. I did. The calculator didn't have inverse T, because that's the calculator, the 83 was the only type of calculator they had back in the day.
Back in my day.
I walked uphill both ways in the snow to school.
There were no cars.
Thanks, Maddie. Took my donkey to school. Oh, goodness.
Giddy up! I'm gonna be late.
Well, I still got this one though.
Yeah, when I was growing up, your landline, not only did you have landlines, but they actually, for when I was really little, by the time I got into, middle school and high school, they were cordless. But for a long time, your phone was on a cord. Couldn't go anywhere.
Didn't you have to like spin the whole thing to call too?
What a nerd.
No, I wasn't that old.
Damn. Can people like listen in on the conversation?
Yeah, you could do multiple lines.
How old was your messenger pigeon?
Oh, that's so funny.
Do you use MySpace?
Oh.
I did not use MySpace, but I've never been a social media person. So I didn't have MySpace. I have a Facebook page, but if you look, I have pictures of my oldest when he was like 2. And he's a freshman now.
It was
So.
like 5'11".
Yeah.
Yeah. Back 5 feet ago.
All right. I want you guys to.
No, we still need your help.
You have plenty of time. The biggest thing with this one, I'm going to move it up slightly, but I'll still leave the conclusion. The biggest thing with this one is that, first of all, I broke it down. So the 4 steps, state, plan, do, conclude, I broke it down. That's state, that's plan, that's do, that's conclude. But with means, a lot of times you're just given a list of data. And that's why when we chose T interval, it asked me if I wanted to use statistics or data. Because if I have the data, I can put it in my list and then just tell the calculator to use that list. So first thing we're going to do here is we're going to type that data into our list. What's up, Pam? A calculator? What have you been doing?
She's just like, she's just raw dogging.
Sorry, I always have my calculator.
She did the old
So
school way.
as you're typing, I'm just going to tell you because maybe none of you have actually read it yet, but this is about biologists studying the healing of skin wounds, measured the rate at which new cells closed a cut made in the skin of an...
A newt.
I know it's a newt, but a newt put to sleep. They're under anesthesia. But anesthetized.
You put so much like unnecessary words.
I really know that the newt is asleep. It's like,
The newt is under anesthesia, okay? They took a random sample of 18 newts. They measured in micrometers. So there's your data. A newt is similar to a salamander, yes.
Baby, they're pretty cute.
yeah, I used to catch newts and then they would just die.
Newt killer.
No, like, my family people
Taking newts to the beach.
like, and I would get a bucket underwater.
Salt water.
When I come to the surface, I would keep it for like a while. And then they
Oh,
would
they're
turn, like,
underwater?
Anywho,
They're a fish?
the first one, define. So we want to estimate
Oh, okay.
the true average rate at which the skin develops new cells. Oh, estimate the mean healing rate. There we go. We want to estimate mean healing rate at 95% confidence. True mean healing rate. And then question 2 is, what is the inference method? That means, what's the calculator function? T interval. And we have to check our conditions. T interval. Random. How do we know it's random?
It says it.
Says it, so I'm going to put the word random in quotations. Normal.
That's it.
It doesn't say it's
No, it
normal,
does.
does it?
It does.
Where?
Where does it
No, it
say?
does.
Where?
Where?
Okay, I believe Zach. It says normal.
Where?
I don't
Wait,
know
what?
where.
No,
It does.
okay, yeah.
What? Where?
I don't know.
Here, you
No, I was talking about random.
That says random, not normal.
We're going to assume normal
Yeah,
so
we-
that we can keep going.
There it is.
No.
This means ready because I don't know if this is what I
It's normal, guys. I swear.
It's right normal every time. So if it doesn't say, should we just assume?
It should have said. I'm assuming I just missed it. I am
If it's
slacking.
not normal.
If it's
That was
not
not
normal, you check to make sure your sample size is greater than 30, which this isn't. Our sample size is 18. So I should have somewhere said normal. I don't know why I didn't.
Or she's just trying to
So
figure out
Zach
the
just did
No,
Oh,
I,
If it's not normal, it's not good.
Trust issues are harder now.
wow, I could have really broke our trust
yeah.
by having you do it wrong and then being like, haha, you did it wrong.
It doesn't meet the
But
conditions.
I didn't do that.
Did you?
There's definitely more than 180 newts out there, as long as Noah's not on that.
Sure.
No one might be.
Noah has really brought that population
Yeah.
down.
I was like a newt now.
All right. So when you do the do part, you should put your X bar, your sample standard deviation. We're gonna go over to hit stack, go over to tests, and you're gonna do T interval. This time we put a list of data in there, so choose data. If you didn't put it in list 1, make sure you put the correct list there. Leap frequency is 1. We don't mess with that. And this time we want a 95% confidence interval.
I didn't look at your.
No, you're recording 4K. She's recording.
You didn't get what?
Digital footprint. What?
Oh, wait a minute. Oh, I got it.
Hannah, when you do your interval, it gives them to you.
It didn't on mine.
Some of the older calculators.
That's an 84. Is it that one?
Nice.
You don't do a lot of math. You just talk.
I think it just whittled a lot back.
Yeah. She does the math, we do the talking.
We're still right here.
That's not my pencil. Please, please, please.
No. You lost my trust. I think I trust you.
Oh, I did.
Wait, so I need, it's actually data that you have?
If you put a list in there, go with the data. Sometimes the problem will tell you, here's the average and here's the standard deviation, then you choose stats and type it. But if you're given a list, choose data.
Here's your calculator. Thank you. This well. Instead of cherries, you should do mangoes.
Mangoes.
Ooh,
Love
they're
mangoes.
They're the same number.
No.
No.
No. They are not basically the same.